Hello students, how are you? I am your old teacher, Kaushik sir. I hope you are enjoying your lives because colleges are not still open. But there is a very good news for you that college will probably open in the next month. Okay. Now our another chemistry teacher has already finished three chapters. First two chapters from organic chemistry. This is haloalkane and haloarine. Next one is aldehydes. Next one is phenol, alcohol and ether, and this is come from organic part, and one chapter come from first part, that was solid state. Okay, now he was a very good teacher. I think you are enjoying there his study. Okay, but today I am going to start with this chapter number 4 from part 1. Okay, chapter is this one. Let's see. Now let's see. This chapter, name of the chapter is chemical kinetics. Okay, it is one of the branch of, let's see, this is the branch of physical chemistry. Okay, this chapter is the branch of physical chemistry. Okay, mainly deals with. Now let's see. Deals with. Number 1, please remember these points, students. Number 1, rate of reactions. This is what? Rate of reactions. Number 2, okay, factors whose affect, factors which affect the rate of reaction. Number 3 point, this is reaction mechanism. Okay, mechanism means how the reactions occur, reaction hota kaise hai. Okay, now let's see, again I repeat, this chapter, okay, this is the branch of physical chemistry, mainly deals with rate of reaction, factors which affect the rate of reaction, and reaction mechanism. Okay, now let's see, what is this? Okay, physical chemistry. Okay, mainly the main objective of physical chemistry is to understand how the chemical reactions occurs. Again I repeat, objective of physical chemistry is to understand how the reaction occurs. In that point, this chapter, okay, this chapter will fulfill the objectives of physical chemistry, to understand the reaction. Okay, how the reaction occurs, reaction bur hoy keneke tumalokor. Okay, before start these 3 points, the rate of reaction, factors which affect the rate of reaction, reaction mechanism, I am going to tell you some concept about these 2 terms. Okay, now let's see. Okay, number 1, now let's see this one. These are elementary reactions. Number 2, this is complex reactions. Okay, now first one is elementary reaction. Okay, now this is nothing but the reactions which occurs in a single step. Means what? If a reaction occurs in a single step, this is called elementary reaction. Jodi eta step ote reaction bor hoy jay, hetu ami ki ko, hetu ami ko elementary reaction. Okay, now let's see. Please remember the statement, students. Now let's say if a reaction occurs in a single step, then it is called what? Then it is called elementary reaction. Now if a reaction occurs in several steps, jodi bahutta step thake, then it is called complex reaction. The second point is this one. if a reaction occurs in several steps, then it is called complex reactions. Simply here only one step, here several steps are involved. Okay, now let's see. Okay, generally one important point I am going to talk about. Generally complex reaction can be represented by several elementary reactions. Means what? In a complex reaction there are many elementary reactions. Okay, now let's see, I am going to describe this with the take of an example. Okay, now let's see what are these example. Okay, now let's see. For example, oxidation of nitric oxide. Okay, this is nitric oxide, you already know this, nitric oxide. Okay, here the net reaction is this one. Okay, oxidation of nitric oxide, the net reaction is this one. Net reaction. Okay, this is first NO reacts with this one. Okay, this is NO2, nitrogen dioxide. Okay, this is the net reaction. After balance you will get this one. Okay, after that, okay, the elementary reactions are this one. This is net reaction. Elementary reactions are this one. Elementary reactions are this one. Let's see what are these elementary reactions. Nitric oxide plus nitric oxide deals with what? This compound is, now let's see, this is dinitrogen dioxide. I am going to write the name of this compound. Dinitrogen dioxide. After that, dinitrogen dioxide reacts with oxygen, you will get what? You will get NO2, nitrogen dioxide. This is nitrogen dioxide. Now let's see, this is a complex reaction. This reaction consists of these two parts. Okay, this is NO plus NO, you will get dinitrogen dioxide. After that, N2O2 reacts with oxygen, you will get what? 2NO2. If you are going to add these two reaction, first, this is first reaction, second reaction. After adding, you will get this reaction, this one. After adding, you will get this one. Okay, after means what? This is complex reaction. These are two elementary reaction. Means what? Elementary reaction which occurs in single step, but this does not occur in single step. This reaction involves two steps. First this one and second this one. I hope we understood the concept. What are elementary reaction? What are complex reaction? And please remember, remember these points. Please remember this statement. All of you, monot rakhiba statement monot rakhiba tomaloke. A complex reaction is always represented by several elementary reaction. Okay, means what? If you add the elementary reaction, you will get finally what? Finally complex reaction. Okay, this is nothing all but the conception of elementary reaction and what? And complex reaction. Now next another important topic is this one. Now let's see. This is molecularity. Simply molecularity is nothing but the number of reactant molecules taking part in an elementary reaction. I am talking about this word, strictly talking about this word, elementary reaction. Molecularity is nothing but the reactant molecules, reactant molecules taking part, number of reactant molecules taking part in an elementary reaction. But we know that in a reaction not only molecules are involved. Eta reaction enukwa nohoy je molecule participate koribo. In a reaction molecule can participate, atoms can participate, and what, and another is ions can be participate. So definition of molecularity can be modified. Means what? The number of reacting species may be atoms, or it may be what? It may be molecules or ions taking part in an elementary reaction is called the molecularity of a reaction. Okay, now let's see. Now I am going to write down the proper definition of molecularity of a reaction. Proper definition. The example tumalake keneke likhiba definition to. Tumalake enake nilikhiba je molecularity is nothing but the number of reactant molecules taking part in an elementary reaction. Tumalake enake example nilikhiba. Kyo question mo kolu no tumalako. Then in a reaction not only molecules are participate, atoms can be participate, ions can be participated. So write like this. Now I am going to write down the proper definition of molecularity. Okay. Molecularity of a reaction. Molecularity of a reaction. Okay. Now molecularity of a reaction definition. Now let's say proper definition. The number of species. Species means what? It may be molecules, ions, or atoms. The number of species. Number of species taking part in an elementary reaction. Okay, whose mass collide simultaneously in order to bring about a chemical reaction. Is called what? Is called molecularity of a reaction. Molecularity of a reaction. Okay, let's see. Please read the definition very carefully. The number of species. Now let's see. These species can be, these are molecules. It may be molecules. It can be atoms, or what? Or it can be ions. The number of species taking part in elementary reaction whose mass collide. Now let's see, all of you please see this word collide. Okay, after 1 or 2 classes, I will surely describe the meaning of this one, collide. Whose mass collides simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Okay. Finally, I am going to again talk you that there are 2 important words. One is species, another is what? Another is collide. Okay. Now let's see. If a reaction, if one molecule is participate, then molecularity will be 1, and this is called unimolecular reaction. Now let's see. Now I'm going to take an example of unimolecular reaction. Let's see. Number 1. Okay, unimolecular reaction. Now let's see. This the name of this compound is, this is ammonium nitride. Please see the spelling carefully. Ammonium nitrite, not nitrate. Nitrite. This is ammonium nitrate. Okay. Breaks like this. This is N2. This is H2O. After balancing, you will get this will be obviously 2. Now let's see. Here only. Okay. Only one, okay, one species are involved in this reaction. So one molecule is involved in this reaction. So this will be what? This will be unimolecular reaction. Here molecularity is what? Here molecularity is 1. Here molecularity is 1. Means what? In a unimolecular reaction, only one species is involved and molecularity is 1. If the reaction involves 2 molecules, means there is a collision between 2 species, then this will be what called? This will be called bimolecular reaction. Now let's see the example of bimolecular reaction. Okay, this is unimolecular. Now comes to bimolecular. Number 2, this one, bimolecular reaction. Okay, example is this one. Hydrogen iodide breaks like this. This is hydrogen and this will be iodine, and 2 will become here. Here molecularity is what? Here molecularity is 2. Okay, molecularity is 2 means what? Bimolecular. Now comes to trimolecular or termolecular. Obviously in that case molecularity will be 3. Tate kiman hobo? 3 to hobo na. Next hobo. This is trimolecular. Trimolecular or termolecular reaction. This is trimolecular or termolecular reaction. Now let's see example. Okay, this is sulfur dioxide reacts with oxygen. You will get what? You will get SO2. After balancing, you will get what? 2 SO2. This 2 will come here. This is trimolecular reaction. Here molecularity 2 plus 1. This will be what? This will be molecularity 3. This will be molecularity 3. Okay, again I repeat. In unimolecular reaction, molecularity is 1. Only one species involved. In bimolecular reaction, molecularity is 2. Means what? In bimolecular reaction, there is a collision between 2 species, and in trimolecular reaction, molecularity is 3. Okay, but molecularity above 3 generally is not possible. Means what? There is a rare condition when molecules more than 3 are collide each other. Okay, you will get these types of concept in higher classes. Why generally collision generally does not actually take place where molecularity is greater than 3. 3 এর উপর হলে generally reaction বোৰ rare হৈ যায়. And আৰু এটা important কথা কৈছো তোমালোকক যে concept of molecularity has no meaning in complex reaction. Complex reaction এবিলাকৰ কোনো meaning নাই কিন্তু generally this concept generally is generally applicable in elementary reaction তে এবিলা তোমাক help কৰিব. Complex reaction মই অলপ আগতে কৈছিলো যে complex reaction generally consists of many elementary reaction. Okay, now comes to the main point of this chapter. Okay, main point. This is the very important point of this chapter. Now let's see. This is what? This is rate of reaction. Okay. Rate of reaction is nothing but the rate of reaction is nothing but the change of concentration of reactant or product per unit time. Means what? Suppose now let's say. Suppose this is the reaction. This is obviously reactant, no? This is তোমালোকে জানাই তো reactant হয়. And this will here. This is product. Okay. As the reaction progresses, generally concentration of reactant will generally decreases. जब reaction शुरू होता है ना, reactant का concentration कम हो जाता है. And with respect to what? With respect to time. Okay. And product का concentration of product generally increases. Here concentration to bahi गई থাকে. Means what? Suppose if you want to calculate the speed of any car, then you should know the distance traveled by that car in a hour and time also. Means what? Speed of a car is expressed generally distance traveled by that car per unit time. Similarly, rate you can also call speed. Rate you can also call speed of a reaction is nothing but a change in concentration of what? Of reactant or it may be product, of it may be product per unit time. ইয়ারও হব পারে, ইয়ারও হব পারে। ইয়ার কিন্তু কি হব? Decrease in concentration, ইয়ার কি হব? Increase in concentration. Obviously product to concentration obviously বেশি হব কারণ ultimately this will be formed না। Now let's say, now I am here using one important word, concentration. Okay, generally, generally concentration is expressed is generally moles per liter. ये generally moles per liter express करा है। Please remember this statement, all of you. Concentration is generally expressed in what? Moles per liter. Moles per liter. Okay, and what? Time is generally expressed in seconds. So unit of rate of reaction will be what? Unit of rate of reaction. Rate means what? Change in concentration per unit time. So unit will be what? Unit kiman hobo sailwa? Rate of reaction. Unit of rate of reaction so kiman hobo pare? Unit of rate of reaction. Change in concentration, and concentration is generally expressed in moles per liter. Moles per liter means what? Mole per liter, and time is generally expressed in what? Expressed in seconds. So unit will be how much? This will be how much? This will be mole per liter. This will be what? Second inverse. Please remember, students, please remember, etu nohoy rate of reaction unit hoy to ekok hoy, moles liter inverse second inverse. Okay, now, okay, I have already told you that generally as concentration of reactant decreases, and generally and what? Concentration of product increases. Okay, as the reaction progresses. Means what? With respect to time, please remember. Now let's say I am going to draw a graph to clear this concept. This is concentration. This is time. Okay, you will get two graphs, one for reactant, another for what? Another for product. Okay. This is for what? This is for reactant. This is for reactant, and this will be what? This will be obviously for product. Okay, now let's see. As the reaction progresses, concentration of reactant decreases, and what? Concentration of the product increases. Okay, suppose this is the reaction A converting to B. So if you want to plot the variation of concentration of A, jodi A er concentration plot koribo lage, this will come here. Iyate ahi jabo because A is here reactant. B will be what? Go to what? B will be go here. This is. Okay, now I am going to do a problem related to this graph. Now let's see this problem. Problem to kenuka hobo tomloke sai lua, bhalke sai lua. The hydrolysis of methyl acetate, the hydrolysis of methyl acetate takes place as follows. Methyl acetate hydrolysis reaction to fast. This is methyl acetate. Hydrolysis means what? Addition of what? Addition of water. Just add water. Add water. Add koriba. Okay. You will get what? You will get finally this product. This is acetic acid, and this is what? This is CH3COH. And generally this reaction take place in presence of catalase. Okay. I will later discuss what is catalase. Okay. Now let's see. H plus. This comes from acid. Okay. Suppose acid is HCl. ये acid से आता है ये. Okay. X as a catalyst. Okay. Now let's see. The name of this compound is what? This is methyl acetate. This is methyl what? Methyl acetate. Okay. This is an example of ester. Okay. To ester is an example. Okay. This is an organic compound. You will get in second book about this compound. But second book about gompai jabat. To like nirostare hikai dibo. What is this? Oh, I am very sorry. There should be L here. Okay. This is ester. Okay. Nirostare will tell you about this compound ester. Now this is what? This is acetic acid. This is acetic acid. Means what? Acetic acid is an example of carboxylic acid. So carboxylic acid is an example of acetic acid. And this is already know. This is what? This is methyl alcohol. This is methyl alcohol. Now let's see. Next part of this question is this one. See very carefully. Plot a graph to show the variation of concentration of this is methyl acetate. Next, acetic acid. Acetic acid. Next is and this one. Students, first please read the question very carefully. The hydrolysis of methyl acetate takes place as follows. This is methyl acetate water reacts with water. You will get acetic acid and what? And methyl alcohol. Just draw a graph to show the variation of what? Concentration of methyl acetate. Second one is what? Acetic acid and what? This is methanol. So graph will be what? Graph will be this type. Graph will be this type. Okay, graph will be this type. This is time, this is concentration, these are for reactant, this is product. First see whether this is reactant or product. This is obviously reactant, this one. So this will come here, reactant will come this side because this graph represents the variation of concentration of reactant. This will come here. CH3, CO, CH3, and this two will come here. This is product acetic acid, this one, and this is one methanol, this one. Please put here this one. Okay, clear? মই গম পাইছো যে তোমালোকে বুজি ধৰিব পাৰিছা গ্ৰাফৰ ভ্যালুবোৰ কেনেকৈ পুট কৰো to put the values. Please see the whether the spaces are reactants and product. If this is reactant, then put here. If there is product, then put here. Okay, now comes to another point. Now let's see what are the factors which affect the rate of a chemical reaction. কি factor a reaction বিক্রিয়া হাৰৰ ওপৰত প্ৰভাৱ পেলায়. Okay, now let's see. देखो फैक्टर्स को देखो ठीक से देखो स्टूडेंट्स. फैक्टर्स affecting the rate of a chemical reaction. Number one factors. This is the number one factor. Nature of the reactants. Number two factor is this one. Concentration, very important factor. Concentration of the reactants. Number three, presence of catalyst. This is very important term, catalyst. Okay, next number four. Number 1, 2, 3, 4. Next number 4, surface area of the reactants. In this case, generally solid reactants are generally considered, and also solid catalysts are considered, because I have already written this term, surface area. Okay, if the reactant is solid or catalyst, then you can clearly understand this concept. Surface area of the reactants. And number 5, presence of light. Very important factor, presence of light. Okay, these are the factors which generally affect the rate of a reaction. Next class I will briefly describe the factors, about these factors, number 1, number 2, number 3, number 4, number 5. Okay, next class I will discuss. At present, please only see these factors. Okay, bye. I will come back in my next class.